In 2004, yet another wonder carbon material, graphene, was discovered. Graphene is a two-dimensional form of crystalline carbon, a parent form of all graphitic structures of carbon, namely graphite, nanotubes, and buckyballs.
This graphene is called as wonder material because of its extraordinary mechanical, electrical and other physical properties. One of the important aspect of the single layer graphene is it shows a quantum Hall effect.
As far as graphene research is concerned, many laboratories are making for various applications, but the role of NPL predominantly is for the development of the voltage standards for the India's electrical and electronics industry.
Graphene is a versatile material and has a wide range of applications. Its high chemical sensitivity makes it suitable for use in laser material and transparent electrodes. Its tremendous strength, much higher than steel, makes it suitable for structural composite materials used in spacecrafts and sports goods. Its 98% optical transparency and high electrical conductivity finds use in mechanical sensors in LED and LCD displays in electronic devices. Its high durability for current density makes it a suitable writing material. Its extremely high charge carrier mobility finds use in high-speed electronic devices like RF transistors. NPL synthesizes graphene by a custom-made chemical vapor deposition technique using copper foil as a catalytic material. Experiments are in progress to grow large-size, high-purity graphene sheets. Well, the process may look simple, but in reality, a host of equipment are actually used to characterize and measure the mechanical properties of carbon products and evaluate them.